Hello, this video is for IXL activity 8.X.5. It's titled Graph Solutions to One-Step Inequalities. Its three-character code is Tango Mike X-Ray. So, solving one-step inequalities. It's pretty much just like solving one-step equations. But instead of working with equal signs, we're working with these arrow-looking things, right? Greater than, less than, greater than or equal to, less than or equal to. And we know that the only difference is that whenever we solve one-step inequalities, if we multiply or divide by a negative number, then we have to change the direction of the sign. So let's go ahead and start working through these. I'm going to rewrite the problem here. We need to solve it, and then we're going to graph it. Now, we've graphed inequalities before, so the graphing part we're familiar with. So we're focusing more so on the solving part, and then we're just representing our answers using a graph instead of writing the inequality. So we have a over 3 is greater than or equal to 2. So the a is tied to the 3 through division. We're going to use multiplication to undo that. We're going to multiply by the number we wish to get rid of, which is 3. And what we do to one side, we do to the other. Sounds terribly familiar, doesn't it? The 3's are going to cancel each other, and we end up with a on the left. We bring down our sign, and 2 times 3 is 6. So now we need to graph our answer here. A is greater than or equal to 6. So let's find 6 on the number line. So we'll click that once to get a hollow dot. Click it again to fill it in, because we want this to be a solid one, because it does have the equal concept. And then the arrow's pointing left, so we're going to send our arrow to the, arrow's pointing to the right. So I'm going to make my arrow on the graph go to the right as well. Matches a sign, right? And we know that that works only whenever your variable is on the left. So you want to use that little trick, make sure your variable is on the left. On to the next one. 2f is less than 6. So 2f is less than 6. So the 2 is tied to the f through multiplication. Opposite operation is division. And we're going to divide by the very number we wish to get rid of, which is 2. And what we do to one side, we're going to do to the other. 2's are going to cancel each other, leaving us with just f. Bring down our sign. And then 6 divided by 2 is 3. So let's go ahead and find 3 on the number line. It's right here. Click once, hollow dot. Click a second time for solid dot. And we want the solid because it does have the equality concept in there with it, because it's less than or equal to. So 3 could be an answer. And since the variable's on the left and our arrow's pointing to the left, that gives us a clue that we need to make our arrow on the graph point to the left as well. And we could always check that and see, and if our arrow went the correct way. 0's a nice one to pick, right? Put 0 in for f. Is 0 less than or equal to 3? Indeed it is. So we know that we have our arrow going in the correct direction. On the next one, this is a little tricky, and oh, we're not there yet. Sorry, thought I was on a different problem. So we have k minus 1 is greater than or equal to 3. So we need to add 1 to get rid of the negative 1. What we do to one side, we're going to do to the other. Negative 1, positive 1 is going to cancel each other out, leaving us just k, and our sign's going to stay the same. Some people see this negative here, right, and say, oh, I need to switch the sign. No, we did not multiply or divide by a negative, so the sign stays the same. And 3 plus 4 is 7, so let's find that 7. Click once for hollow dot, for open dot. Click a second time to close it in, and this one also has the equality concept. And this is the sign's pointing to the right, so let's make our arrow go to the right. We can do that because our variable is, yep, it's on the left, so we're good to go. And we could even check our answer, pick out a number in that section that's highlighted here on our graph. 10 is part of the solution set, so plug in 10. Is 10 greater than or equal to 7? Indeed it is, so we know our arrow went the correct direction. You can always check your answers like that by selecting one of the numbers that's in part of the graph that you highlighted is your answer. From this point on, I'm going to stop checking those answers. But I just want you to know that you can always check and make sure that you got your graph going in the correct direction by grabbing one of those number values, plugging it in for the variable, and then see, does it make a true statement. All right, so on this one, we have 3 is less than m minus 1, and I do notice that our variable is on the right side of this inequality now, so we're probably going to have to do something a little later when it comes to graphing it, but we'll deal with that whenever we get to it. Let's go ahead and solve for m first. So I have a -1 here, so let's add 1 so I can get rid of that -1. And what I do to one side, I'm going to do to the other. -1, +1 is going to cancel each other out, right? Leaving with just m on the right. 3 plus 4 is 7. Now, whenever I go to graph this, I already know that it helps if my variable is on the left instead of the right. So we're going to send the m over to the left side. We're going to send the 7 over to the right side, but we're going to have to flip our sign. All right, so this we're flipping the sign not because we're multiplying or dividing by a negative. We're flipping the sign just because we're moving the variable from one side to the other and the constant from one side to the other side. If you were to think about it as a scale, right, if the scale's uneven, and I'm trying to get my hands in the picture there, that if we had a scale, right, and we had the m's greater than 7, so m would be way more. If we had, right, and so this is what we have here. Right now what we're looking at is 7 is less than m, which is that. And then if we flip them around, notice that our scale would look something like this, right? If we changed them and we put the m on the other side, right? If we put our m over here and our 7 over here, then the scale's just going to change and lean the other, or teeter, you might say, in the other direction. So just like if you were to switch their sides, the scale would change the way that it's leaning, well, also the sign has to change as well. All right, so moving along, we have 1 is less than or equal to h minus 3, and that's an h, not an n, so we're going to put a little bit taller there. And I need to add 3, right? Get rid of the -3, and what I do to one side, I do to the other. The -3 and +3 are going to cancel each other. I'm going to bring down my h, and then I have a 4 here. And then if I want to use this for a little bit of a hint in graphing, I can move the h over here, flip the sign, and the 4 there. And then I end up highlighting 4, right? It does need to be closed dot because it has the equal part, and it's now pointing to the right. That is to say all numbers greater than or equal to 4. And so there we go. And as I was doing that, did I graph that last one? No, I did not graph that answer, did I? So I guess I need to go ahead and finish that out. M, 7. Did I mess up? Oh, I see what I did. I added them together already. I was thinking of the answer already. So, silly me. If you were watching that, you're like, man, you got that all wrong, Mr. T. So we need to go back, don't we? Let's go ahead and clear this up. I'll leave my scales there for now. I was correct in adding 1. I needed to add 1 to each side, and then the answer is 4. So I went ahead and I wrote 4 in there. My brain got ahead of itself, right? So there we go. And M, switch the sign, 4. There we go. And the reason for that was, as I looked up here, I'm like, there's no place to graph the 7. That's a good clue for IXL. If you solve it and that number's not there, you need to go back and check your math. So here I have 4 is less than m, so that'd be 4 is less than m. And here, flipping it around, that'd be m is greater than 4. So now I can go ahead and graph that. Good teachable moment there. The idea that, first of all, teacher's not always right. I can get in a hurry too. And then also that I would not have thought of highlighting the fact that if you get an answer that's not somewhere on that number line, then chances are that you messed up someplace in your calculations. So let's find 4. And this is a good one because I think this is the first open dot question of the whole activity, right? And notice it doesn't have the equal concept, so 4 is not included. M has to be greater than 4, so we're going to go ahead and leave that as an open dot. And there we go. Outstanding. On the next one, here we have 3. This is the one that I was saying is kind of like a 2-step inequality, because we're going to have to first get rid of the 3 by subtracting 3, and what we do to one side we do to the other. Think of that as 5 plus a negative 3. All right, it's going to get even more negative, so this is a negative s, so bring down negative s. Let's keep the sign the same for now. Those 3's canceled each other, right? And negative 5 plus negative 3 is negative 8. So now we can't leave this as a negative. But remember, whenever we're doing regular equations and we had something like negative x equals 5, and we knew, oh, I can just go ahead and change that and change that, right? Just give them different signs. Well, that's because we're dividing by a negative 1. And we can't leave this s over here as negative. So we need to divide by negative 1. And what we do to one side, we're going to do to the other. Now, we're dividing by a negative, so the sign has to change. So now we can go ahead and end up with that, and end up with that. Basically, if you look at it, we kind of think about it this way, the signs did change. We just made both of them, the idea is if you're going to change the sign, the negative to a positive on the variable, you have to do the same to your constant as well. So whenever I did that, I had to change the sign. So now I'm ending up with s is less than 8. So let's go ahead and pick this here. We're going to leave it open dot. It's pointing to the left, so let's go to the left. And remember, we can only do that because the variable's on the left. Use that little sign there. And then let's go ahead and check this one, because this one here is a little bit different. So let's go ahead and select 0, right? 0's there as part of our solution. So I plug in a 0, 3 minus 0, greater than negative 5. So 3 minus 0 is what? 3, right? Is 3 greater than negative 5? Indeed it is. Checks out. We're good to go. All right, so moving along, we have negative 16 is greater than or equal to 4t. Let's go ahead and divide by positive 4. So we're dividing by positive 4. Now notice we're dividing by a positive. Now you do see this negative number here, but just because there's a negative number doesn't mean we change the sign. Right? So the 4 is going to cancel each other. It's only if we're multiplying or dividing by that negative. So here we have a negative divided by positive is negative, and 16 divided by 4 is 4. Now I like my variables to be on the left, so I'm going to move the t to the other side. They're going to switch places, but I'm going to switch the sign. And then t, negative 4. It does have the equality part, so we're going to click that again to get a solid dot. And we're going to go ahead and graph to the right. On the next one, we have negative 14 is greater than 7b. So let's go ahead and divide by 7, right, to get that b isolated. And what we do to one side, do to the other. The 7's are going to cancel each other, leaving us just b. And negative divided by positive is negative. And 14 divided by 7 is 2. I like my variables on the left, so I'm going to move my b over there, and my negative 2 over here. I do need to switch the sign, so now find negative 2. Here it is. I'm going to leave it as an open dot, and I want it to go to the left. And so that's my final solution here. On the next one, I have 30 is greater than 22 minus b. So let's get rid of this 22 by subtracting 22, minus 22. And we're going to subtract 22 from the other side as well. Let's leave our sign for now. Bring down our minus b, because the 22's canceled each other. 30 minus 22 is 8. Now I want to, I'm going to end up flipping a couple times. Let's go ahead and move the negative b over here for now and change the sign. Right? Sign changed because we flipped them on the other side, just like changing places on the scale. Now let's go ahead and divide by negative 1s. And that's going to give me a positive b on the left. But I divided by negative, so the sign has to change again. And I'm going to get negative 8. So I do have negative 8 up here. I'm going to leave it as an open dot, right? Because the sign is just greater than, not greater than or equal to. And to the right. I could always check that out. Select 0 is a good one. 22 minus 0 would be 22. And 30 is still greater than 22, so I know my answer is correct. Here I have 2 minus b is greater than negative 4. Let's go ahead and subtract 2 from each side. Remember, subtracting 2 is like adding a negative 2, right? And so I'd have minus b, or negative b, is greater than, because the 2's canceled, negative 4 plus negative 2 is negative 6. Now let's go ahead and divide by the negative 1, right? So that's going to give me b dividing by negative 1. Changes the signs on those two, but I divided by negative. So let's go ahead and flip our sign. And now I can go ahead and graph my answer, right? That's a b, not a 6. So b is less than 6. So finding 6, we want open dot, right? And it's going to go to the left. And again, selecting 0 might be a good one to check out there. 2 minus 0 is 2. Is 2 greater than negative 4? Indeed it is. Here we have 15 less than, equal to 13 minus n. Let's go ahead and subtract the 13 to get rid of the 13. What we do to one side, we're going to do to the other. And we'll leave our sign there for now. 13 is going to cancel, leave me with negative n. And 15 minus 13 is 2. Let's go ahead and switch their sides. Okay, so let's put negative n on the left and 2 on the right. But by doing so, we have to switch the sign. Now let's divide by negative 1. All right. And so negative divided by negative is positive, so I'm just going to get n. 2 divided by negative 1 is negative 2. But I did divide by negative, so I need to switch that sign, right? So we're going to switch that sign going the other way. Now we can go ahead and graph our answer, finding negative 2. We do want it to be closed dot because it is less than or equal to, so negative 2 could be a solution as well. And we want our arrow going to the left. Now, here's an example of how you can use a number that's not a part of the set of the solution. So 0 is not highlighted. So 0 should create a false statement, right? So if I did 13 minus 0 would be 13. And then we would have 15 is less than or equal to 0. Is this true? No, that's not true. So, and that makes sense because I selected a number that is not part of the set of the numbers that's solution to the inequality. So, using numbers that aren't part of the solution can also help you find out if your arrow went in the correct direction. Here we have 1. It's greater than negative 3 minus q. So let's go ahead and add 3 to each side. I almost said add 4 because my brain was adding those together already over here. So yes, I would have 4 over here. The 3's are going to cancel each other, leaving me with negative q. Let's go ahead and switch their sides because I like my variables on the left. Had to switch the sign whenever we switch the sides. Now let's go ahead and divide by the negative 1. And whenever I divide by negative 1, the arrow is going to change directions, correct? That's going to leave me a positive q on the left. No, this is a negative 1, so I'm going to get negative 4. So finding negative 4 here, and should be going to the left. And I could always plug in a 0, right? See if it produces a true statement. Negative 3 minus 0 would just be 1 is greater than negative 3, and that is a true statement. So my arrow is in the correct direction. And I'll be doggone, I look up and I don't have any more problems to. So That concludes all of my examples for IXL 8.X.5 graph solutions to one-step inequalities. Good luck with your activity.